Okay, good afternoon. Thank you very much for inviting me and for the warm welcome. I would like to talk today about music data science, about semantic web and machine learning in this context. And this is what I'm going to talk about. I have a number of slides, but I'll try to be quick because I realize that I'm between you and the coffee break. So I'll try to keep it short as much as possible. At any time, feel free to ask questions if anything is unclear. I'll probably gloss over some of the details. So I wanted to talk a bit about the context in general for music data science, but also, of course, a bit of context about me, then the music data science, why I think it's a relevant term, what it means to me. I'll give you examples from projects that I have led or been involved in, and talk about feedback from musicologists and about conclusions, what we can do in the future. So, about me, I have I'm a kind of a mixed person hybrid. I've worked in mathematics, computer science, and music, so I'm probably one of the very few computer scientists with a PhD in musicology. I'm now an academic at this City University of London in the Department of Computer Science, and I'm a member of the Research Center for Machine Learning as well as the Interdisciplinary Data Science Institute, and I have a small research group where we do music informatics and machine intelligence. What I've done in the past are things mostly related to audio and symbolic analysis of music in respect to this topic here. I've worked on technology-enhanced music education, written software. The computer colleague Musik is something that's kind of people in the German-speaking world know often. They use it to prepare for their oral skills exams. And I've also worked on other projects related to harmony, grammars, and rhythmic analysis as part of my master's work and PhD work. And then we really realized that we need machine learning to do these things. And then machine learning needs data. So we need ground truth and we need the data examples. So the next project was on object-oriented music representation, where we tried to organize data. And then when I moved to London, the next project was on music education using these technologies. And the projects I'm going to talk about today include big data systems for music research. And I also do general machine learning and deep learning research, including things like transcription and audio source separation. But I'm not going to talk about these today. So why is this relevant for creativity, for interactive tools? Well, I think that intelligent, if you want to put that maybe in inverted commas, but intelligent creativity and interaction in music and music technology needs context. So you need to know what the music means, and that's more than just sort of analyzing the audio. And musicology is the field, the discipline that is concerned with this question, like what is the context for a piece of music or for an element of music. And of course musicology uses data because we use scores and we read scores, and that's data in the widest sense, but data nowadays is different. And what can the contribution be? Well, one example we've done, actually, there was what was called the world's first computer-generated musical beyond the fence, and we did actually the preliminary research for that, so music information retrieval, trying to understand structures in musicals. And the task we were given was a slightly crude one, like what are the differences between the successful and the less successful musicals? And we did actually find some statistically significant differences. That doesn't give you a recipe to write a good musical, but it gives you some interesting facts, and that's where musicologists are obviously needed to interpret the facts. What does it mean if I find more subdominance in the less successful musicals? Anyway, this musical was created and was advertised as being the first computer-generated one. I have to probably qualify that. I mean, there's a lot of computer-generated elements in it. It is not end-to-end computer-generated. There's also a lot of human creativity in the music, in the story, in the text, and everything. Yes, and talk a bit about linked data and that the AI that everybody's talking about today needs some kind of background knowledge. And if you think back to classical AI, this was what people talked about. We need world knowledge for our systems, because if we have all these rule systems, how are they going to know about the world outside? And to some extent, this is what Semantic Web is trying to do. Okay, so digital musicology. Well, as has been mentioned today, the music scene has changed dramatically. Nowadays, everything is digital. What does that mean for musicology? Of course, musicologists could decide to ignore that, but that doesn't seem like a really attractive option. So what can we do? We need to somehow develop some kind of smart, scalable digital musicology that can address these large data sets. And we need to have interfaces that make it workable, because most musicologists are obviously not computer scientists. And we need to have interaction between musicologists and technologists. So I love the example that Peter gave earlier, that what happens quite a lot is that that technologists think this is what's needed, they build it, and then the people who are supposed to use it, like musicologists, say, no, actually we want something completely different. And that's normal. And you have to find ways of creating a dialogue that enables a co-creation of these systems, so that makes sense from a user perspective as well as from a technological perspective. But we should still try to build these systems. At least there are musicologists who think that working with larger data sets will open up new areas of musicology. Yes, so we have large data sets available nowadays. The Internet Archive has 8.5 million audio tracks. They're not all music, but still, it's a large amount. Acoustic Brains has a feature extraction for over 4 million tracks. British Library, this is an organization that we work with. They hold more than 3 million audio recordings. I haven't found a more recent number, but at the time when we worked with them, they had more than 3 million, and about 10% were digitized. I think that probably number has gone up, but they have 1.5 million music prints, 100K manuscripts, and commercial datasets are way bigger. So Apple, Spotify, and Google, they have like more than 30 million. Again, that number is probably outdated. So I think what that shows is that this is beyond manual analysis. Nobody can even listen to all this or read it, or let alone do detailed analysis. That's simply not possible. And the paradigm that has been created by humanist researchers is called distant reading. So that was at least a concept by Franco Moretti, with the idea that we use, instead of doing the close reading, which most humanities researchers do, by looking at one artifact in great detail and coming up with deep, profound interpretations, we need tools that enable us to look at things in a bigger perspective. So we need the tools to do that. It's a bit like an astronomer uses a telescope to look at things far away. So if we need to look at things that are really big, we need to have the tools to do that, because the traditional way doesn't really apply here. And the point is that these tools are not really there yet. There is the term semantic gap has been bandied around a lot, and it's kind of seems outdated, but it's still there. We still have a semantic gap. It's not that music technology has solved everything. So we have still not really found a way to deal with large heterogeneous data collections. The integration of audio and symbolic processing is still not commonplace, and we need machine learning for information extraction, but it's not perfect. And we need more context. That's one of the feedbacks we keep getting. And we need the software infrastructure to do it, and the tools and the visual interfaces. And last but not least, we need from the musicological side the methods to work with this kind of approach. So music psychology has, of course, for a long time been working empirically, but usually on very small data sets. Ethnomusicologists know how to interpret audio recordings, but they do it largely manually. So how can we bring these things together to deal with the opportunities, or to make the most of the opportunities we have today? And my impression is that it's beginning, but it's not very much happening at the moment. And most music data is at best medium-sized, but still too large for manual analysis. And most music research is not yet data-driven. So where are we in this respect? So here are some ideas about, or some, not ideas, but examples of big music data applications. And as was mentioned by Peter, recommendation is the most popular one, the most common one, because it has most commercial relevance. So these systems are designed to recommend a track to you that you are likely to buy or to listen to, so that you stay on the system or that you pay something for this track. A really early one was Live Plasma, and the more recent ones like Apple Music or Spotify are have a, I guess, more reduced interface. They focus on just delivering the thing. Now there's some text missing. What this last line should be saying is not, this is not the same as understanding the music in any meaningful, human meaningful sense. This is just trying to have a good guess at what the next person might want to click on. It's a bit like this example. If we learn how to give the correct answer to something, does it really mean we have understood it? And often it doesn't. So existing, one slightly more interesting example, something that looks a bit more like musicology, is this one. I think this is also about 10 years old, from Google, where they plotted over time how different the popularity of different different genres of music. But it's rather crude. It doesn't look into the music at all. It works on metadata, and then there are lots of open questions. What is it that we're looking at? What does it mean? Because in the 1950s, it's probably not the case that 80% of all music was jazz. What this means is that probably among the users' collections, the tracks that are from the 1950s, a lot of them are jazz. And also this refers, of course, to the date of the recording, or maybe even the release, not the date when the music was composed. So there are lots of subtle but very relevant issues that are usually glossed over in this kind of approach. Another example that Matthias Mauch and his collaborators made a bit of a splash in 2015, 5 years ago, where they wrote about the evolution of pop music, and they applied a latent factor model to a collection of audio recordings that were in the Billboard charts for the last 50 years, I think. And so they looked at quantifying change, and their conclusion was that there have been 3 musical revolutions here, like rock and roll, British invasion, and rap. And that was challenged. I mean, they got into the news with that, but they got a lot of challenges from musicologists that I would agree with, because this is an oversimplification, I would argue, and it's also not clear what are we actually using to say this. Is our measure, it may be a quantitative measure, but is it a relevant one? We don't really know. How does this correspond to music, how it's made, or music, how it's perceived, or music and its cultural context? It's not there, it's not clear. So one thing we did to try and address this a lack of methods and systems was a project called the Digital Music Lab in 2014-15, was AHRC funded, and a collaboration between the city, Queen Mary, UCL, the British Library, and contributions from a company called I Like Music. And we wanted to develop an infrastructure that enables this kind of work. Okay, I'll speed up a little here. I think I've said most of the relevant things. So the data flow is that we need some kind of user interface. In this case, it's a web-based interface. We need to have some kind of management of the underlying analysis of our data, which is done by a system called Cleopatra. So Prolog-based for those who are interested in the technology. And we need databases where we have existing results that are then fetched once they're needed again. And if the results are not there, then we need to compute them. So we have computing servers that use Spark, which is a system for distributed computing. And then this system has to have access to actual audio, and it calculates what we call features. So this is the information extraction part that Peter was talking about. So it does things like trying to transcribe audio into notation, or like trying to recognize the key, trying to recognize the chords, trying to recognize the time signature and where the beats are. And all of that is done with machine learning, but I'm not going to talk about that much. So we have built this system. It was a kind of a short, thick project. So we had several people working, but it was only 15 months. And we have a data set with derived data about 4 terabytes. It combines data from the British Library, Charm, Mazurka's data set, and the I Like Music data set, which has about 250,000 tracks, mostly pop music. The other one is more classical and folk music. And we built a web service with the visual interfaces and software. And we built this interface that I want to show you live now. Yes, okay, we're on the wrong tab. Oh. Where's the mouse? Here. So here we are. So this is what the interface looks like. So we have columns that correspond to selections of data that we can make by saying we want something from something from the Charm data set or Charm library. We said we want things that have been composed by Mozart, and we can then create multiple such columns, and then we create different rows that have different features. So the first one is just it lists some of the recordings. Then we can have a tonic histogram, so which keys are present how often. And then pitch class histograms and fine-grained pitch class histograms, tempo histograms. And just for fun, I've added some music from Mali, and we can, for instance, observe some differences in the distribution of keys, but the concept of keys probably doesn't make too much sense in music from Mali anyway. But what we can see, for instance, is that the fine-grained pitch histograms very clearly correspond to Western scales. Everything is nicely tuned to A somewhere near 440 hertz. And so we get this kind of comb-like structure. And in the African music, that doesn't happen. They don't use the same scale. So we see differences, but one thing that is important is these differences need careful interpretation, because it's clearly not not easy. There may, for instance, be artifacts, like do the tools that we use or the feature extractors really apply to that kind of music? Does the concept of key make sense in African music in the style that is used in Mali? all these questions need to be answered to derive meaningful results. But we need some kind of infrastructure to explore the data and to get a first impression where we are and where it may be worth looking in more detail. We have built one more specific visualization for chord sequences. So here we have, we can see the transitions between different chords that belong to different, have different roots and different qualities. Might be a bit hard to see here. And you can visually see that blues and jazz look different. So distribution of keys is different, distribution of the chord types is different. So this is what we would hope to see, because if we didn't, we would be concerned. But then, so this is basically a tool to do exploration of the data to get some idea what to look for. So what can you do with this? We did a few example studies. So one was on temperament. Temperament has the advantage that it's something that you can actually measure. So you can, there's no discussion about what the actual frequency is. There are methods for measuring it, and then you can determine the actual measured temperament. How close is it to the measurement that, to the temperaments that we know, and does it actually correspond to what it says on the cover? Sometimes it doesn't, because differences are very subtle, and you can see. But we can see that there are changes over time. And one interesting one is that I think it was the Lehmann tuning, if I remember correctly, not sure. One was only developed like around 2000, but it apparently in practice it appears before. So the mathematical derivation came later. Another one, the chord patterns I already mentioned. We can see that, for instance, in jazz, we have more variety. So we don't get very many long chord sequences that appear very often. While in folk, for instance, we have a lot of long chord sequences that appear often, so they're reused. Now that, again, these need to be checked and interpreted, but this is kind of what we get out of the data. So it's worth thinking about what it actually means. So a possible hypothesis might be that folk has more long patterns because it's in some sense more formulaic. But I wouldn't put that out as my conclusion yet. Here's another one. We can look at these chord transitions by visualizing the frequency or the relative frequency with the thickness of these arrows. And again, we see differences between classical music and blues. And here we're not using the absolute chords, but we use just the qualities, so major, minor, dominant, and okay, I'm not going to go into too much detail because it's we'd be running out of time. More visualizations of sequence patterns, folk versus jazz. Third example was, I thought, an interesting one where data comes really in useful. So there was a claim in a study by Richard Parncott from 1994 that the most salient tempo in music is around 100 beats per minute. And we matched that with European data, and it seems like a good fit. But if we use that on other cultures, the picture is more mixed. Now, does that mean it doesn't apply to other cultures, or does it mean our tempo trackers don't work well? Interesting question. We need to answer that. But it enables us at least to ask questions and get some direction where to go. Because it might be we would get exactly the same picture, and then we would say, okay, it applies everywhere, or everywhere we have data for. We did a final workshop on this and asked 40 musicologists questions about it, and one of them was, these kinds of tools could be helpful with my task. Strongly agree or strongly disagree, and we got very positive feedback. And I hope that we're not all being polite, but they seem to genuinely like it. But the most frequent question we got was, how can I relate this to the historic, geographic, cultural context? Can I ask things like, do people in America play jazz differently from Europe? And we figured out we don't really have the metadata to do that. We don't really have the tools to do that. And so one way we addressed this, or started to address this, is in a more recent project called Dig.Lick. This is a transatlantic platform digging into data challenge, funded this project. And this was again with Queen Mary. They led the project. Columbia University, us, University of Illinois, Musikhochschule Weimar, and IRCAM. So large international collaboration, people doing different things here. And we developed infrastructure that hopefully will enable us, or that to some extent does enable us to understand the use of melodic patterns in jazz corpora. Okay, I have to speed up. So structure is similar. We have a stronger metadata component here. And we figured that we had to build an ontology, because the ontology enables the semantic web connections for things like sessions that don't exist in common music technology ontologies. A session is important for jazz musicians because in a session people play together. But a session is not necessarily the same as an album. An album may consist of multiple sessions, but it's not the same as a song. So we thought it should be useful. It would be useful to model this, and we did. And we also collected metadata, and there are many enthusiasts who collect this data, but it is really difficult to make it consistent. So the metadata cleaning had to deal with things like Charlie Parker with how many different spellings? 10. There's probably not all the spellings and not all the sort of terms that we had. Then dates like circa early spring 1946, bit difficult to get that into a database. And then we have the common abbreviations for instruments. So bass in most cases abbreviated as B, but it might also be ELB for electric bass, or synth B for synthesizer bass, or fretless or string, or fretless electric, or electric fretless, or keyboard or amplified, or just bass as a word. And you have to map all these things. So it's a labor-intensive process, but again, you need to do these things and to pay attention to the detail if you want to actually understand your subject and not just do statistics that enable you to make a good guess. Yes, things like reconciliation, the people don't agree on the date of birth for Louis Armstrong. And there are two different people called Bill Davins. One plays piano, one plays soprano saxophone. So all of these things need to be taken care of to get reliable information and not just sort of a big data mix. So patterns are, people agree that they're important, so I'll skip this slide. And we used automatic main melody extraction with deep learning, as one does these days. And it works reasonably well, not perfect. So machine learning people are always happy when they get 85 or 90%, but you have to consider that means probably 10% of your notes are not correct in some way, and that might actually be a problem for many things. We've created data set, not that big, but it was not that easy to get hold of the audio and to do the transcriptions and to get hold of the metadata. So metadata turned out to be a big chunk of the work. And we've implemented a pattern search and a pattern similarity search, and I'll do a very quick demo of those. So here, this is what people call the lick. Oh, we had it already. And for the Weimar Jazz database, we actually have transcriptions because we have all the necessary information. Can even play them in context and we find so we have two exact matches for this lick, and here we then have the pattern similarity search, slightly different lick, where we can say we now are interested in similar patterns, and then we get more hits, and then we can look at how they relate, for instance. So we can draw for these network graphs according to various criteria, and we can also draw a timeline. Where's the timeline? I think the button is somehow hidden. Anyway, I'll just go back to... So the timeline looks like this, where you can see when a specific pattern was used by different players. So we can see here we have Branford Marsalis here, Charlie Parker here, Gary Mulligan, Freddie Hubbard, Joshua Redman. So at least we're making some progress towards understanding a bit better how patterns are used in jazz, how they travel between different artists, and we can then use the metadata to also try and make inferences about how they travel over time and geographically. And well, the project has just ended, but we're still working on analyzing the data and doing more with this. The challenges are generally here that data is not necessarily easy to come by, especially audio data is typically copyrighted, and metadata often doesn't exist or is not publicly available at all. Machine learning is great, but it's not perfect, so we need to figure out ways to get even better accuracies, and the need for context that was so clear, we need to do something about this. And Semantic Web seems to be the tool to do that, because it enables us to link to different resources like Wikipedia, like authority files from libraries. And finally, we need musicological approaches to deal with this kind of information, which is of course very different from just reading a score, so it requires a different skill set. And what exactly that is, I think, is still a question that has to be answered. But I think it is important to answer because it will help us to develop a better understanding of music, and it will contribute to all the interactive tools that we're going to build, hopefully, in the future. And so here is a result, very briefly, on what musicologists dream of for their systems. Things like empirical music research with more big data, like collaborative studies, personal collection space, and the yellow light indicates, or amber light indicates, that we have some tools, but we're not there yet. We don't have what people actually want. So, okay, I'm not going to read that out. In one word, I think musicology needs different tools for the resources that need to be analyzed and studied today, and providing these tools is going to be helpful for musicology, but it's also going to be helpful for technology, because it will provide more contextual information and better understanding of the phenomenon that we're dealing with of music. And hopefully musicologists will also find a way to engage more with the development of this technology. And this should have a positive impact on more interaction and creativity in music technology. And there's a lot of more work to do and more funding needed to do it. Okay, thank you very much.